we're going to talk in 7.2 about operations on decimals. 7.1 we just talked about what they were, how we say them, how we would write them in language and whatnot. 7.2 is going to be looking at doing things with them, operating with them. And so when we're operating with decimals, the first thing we're going to look at is addition and subtraction. So when we add and subtract with decimals, what we do is we line them up so the decimal points are on top of each other, kind of like I did when I just did that comparison problem. And then we sort of add like the way we always add, right? Moving typically from right to left, and we carry things when they get too big and all of that stuff. I want to show you why this works though, and this is an important idea, and it relates back to fractions, our favorite. All right, so what I want us to do is I want us to think about the expanded form. This was section 7.1. How do I write 4.33 in expanded form? Take that and we're going to shorthand it a little bit. This is 4, it's 3/10, and it's 3/100, right? Literally this is $3 bills, sorry, $4 bills, 3 dimes and 3 pennies. You can physically see that happening. All right, we can do the same thing with the 326, 3.26. So you have the 3 times your 1, you have the 2 times 110, and then the 6 times 100. So I can, again, shorthand this a little bit to think of this as 3 2/10 and 6 hundredths. So the reason this is going to work, this whole lining things up bit, is because the fractions that you can combine easily are the ones that have the same denominators, right? So I can very easily combine the 4 and a 3 to get 7. I can easily combine 3/10 and 2/10 because they have common denominators to get 5/10. And then I can easily combine the 300ths and the 600ths again because they have common denominators to get 900ths. This isn't the only way that you could write this out, but this is one way. And then you see the 759 from the expanded form back into a decimal. That's why it's working, is because what those locations of those decimal points mean is as they're related to fractions. Okay? So that's why we're able to do that. Now let's actually do one, and we're going to do one with subtraction instead of addition, since we just did the addition. All right. A stock's price has dropped from $63.28 per share to $27.45 per share. What was the loss on a single share of this stock? So what am I going to do? Okay, so what am I going to write first? Which number first? The larger one. And then subtraction, and up at the smaller one. And I have to line the decimals up with subtraction or addition. That's not true for multiplication and division. That's why I'm harping on it right now, is because this is really unique to addition and subtraction. But then my subtraction occurs just like from before. So I start on the right-hand side, and I would take 8 minus 5, and I would get 3. And then I run into a problem because I can't take away 4 from 2, so I have to borrow. Now, depending on your background and thinking about what borrowing does, let me remind you, for those of you who've heard it, and tell you for those of you who haven't. What we're really doing is we're really taking a dollar bill, one of those 3, this is $3 on top, right? I'm taking one of those dollar bills and I'm turning it into what? 10, literally 10 dimes, right? So I have 10 dimes, and I already had 2 dimes for how many dimes? 12 dimes. I mean, literally in this problem, those numbers actually mean money. So that's really what's happening. You're turning 10, the one that was right here, one of these 1 units, one of these dollar bills, into 10 of the next item. It's 10 dimes. So now I have 12 dimes, and I take away 4 dimes, and I get 8. And then I have the problem again because now I have $2 bills, and I'm supposed to take away $7 bills, and I don't have $7 bills to take away. I know we're ignoring the 5s, which is like 3/4 and things like that. But I've got a 6 here. So this is 6 tens. This is like a $10 bill, right? I can take one of those $10 bills and I can turn it into 10 ones. I already have 2 ones, and 10 more ones would give me a total of 12 ones. So if I had 12 ones and I took away 7 ones, I would have 5 ones. And then I can do 5 minus 2 just fine and give me 3. And this is $1, so we need the dollar symbol on there as well. So this is $35.83 with the loss in the signature store. Okay, let's do multiplication. So with multiplication, we multiply as usual. We don't have to do any lining things up. None of that going on. You just multiply. Kind of ignore the decimals. But then at the very end, you go back and you do a counting argument. You count the number of decimal places that originally the problem had in all pieces, and then you give your answer that many decimal places. So let me do an example with this one, and I'm going to show you first what that's describing, and then we'll actually talk about why that works. Okay? So this is 0.3, so that's actually like having the number 3 times 7. Now, these look like they're lined up. They wouldn't have to be. But what's 3 times 7? 21. How many values are there, non-zero? How many values are there after the decimal places if you added them all up? There are 2. There's 1 after the decimal point on the 0.3. There's 1 after the decimal point on the 0.7. That's 2 places total. So my answer needs 2 values after the decimal point. So my decimal point is there. That's an algorithm. Okay, that's how it works. Not how it works. That's the way it works. Right? This is what we do. But I want, again, to draw you back into why does that work? Why in the world? Because that seems a little mysterious to me. Why in the world, when we do addition and subtraction, do we just pull the decimal down? When we do multiplication and division, we do this funny little counting thing and moving. Doesn't that strike you as a little bit strange? No, because you've done it all your life, right? But when you have that obnoxious little 10-year-old saying to you, why, it'd be good if you could come up with something that makes sense. Not just because that's the way you're supposed to do it, which is probably what you guys have heard most of your life too, right? That's not a very good teacher response. So it happens. But it's not the best one, and we'd like to have some other option besides it. So let me show you why it works. All right, what is 0.3 as a fraction? 3 over 10. Oops. What is 0.7 as a fraction? 7 over 10. And we worked so hard in the last chapter about establishing how to multiply fractions. How do you multiply 3 over 10 times 7 over 10? Multiply them across, right? 3 times 7 is? 10 times 10 is? 100. And that is read as 21 hundredths, which has a decimal form. It looks an awful lot like the one that that algorithm that somebody told you some normal day gives you. And that's why. Okay? So the method you know has a reason behind it, and it's based on fractions. So fractions are so important because everything you do with decimals is based on fractions. Now I get it. All right, we're going to stop there for today. We'll do the division next.